Well, students, today I am going to discuss a very important chapter, that is ionic bonding. We have already learned about atomic structure, and this chapter is very much related with the electronic configuration of that particular chapter. So without understanding the previous concept, it will be very difficult for students to understand the chapter properly. I hope you have learned the previous chapter. Even if you do not learn it, please see my videos on my lecture on atomic structure, that chapter, and hopefully you will understand atomic structure. Then it will be very easy for you to understand this bonding. Well, now let me change the slide at first. We are going to learn these topics here in this video. The topics are introducing bonding, then making ions, ionic bonding, formula of ionic compounds, properties of ionic compounds, and some summary activities. So now let me introduce what is bonding actually. We know that there are so many different types of substances available in the earth. Among them, elements are the fundamental substances, and number of elements are very limited in the earth, only 118 so far discovered. But number of compounds are millions. There are some unlimited number of compounds in this earth. And wherever how now the question is how so many compounds are available. The answer is very easy. The simplest substances like elements, they combine with each other in various ways, and they are forming so many substances in the earth. Now the question is how these elements combine with each other. And the idea bonds come from here, from that question. Whenever an elements have some attraction towards another element, then they form a compound. So the attraction force by which elements are combining together, that is actually bond. So we can define bond in this way. Thus, that is the attraction. It is actually the kind of attraction force is responsible for this type of bonding. Okay, so here we are going to learn how different types of attraction force is formed. Okay, let me clarify it gradually when we will progress the slide. So now let's see just one example. We know that chlorine is a diatomic molecule, right? So whenever chlorine molecule is formed, we get Cl2 by the combination of two atoms of chlorine. We get chlorine. So it is also a kind of bonding. We will learn about the types of bonding gradually, and also in water, we know that water is formed by the combination of two hydrogen atom and one oxygen atom. Here, oxygen and hydrogen has also kind of attraction. That is why we are getting water. Well, now let me change the slide first. As I have mentioned before, to understand about bonding, first we need to focus about the electronic configuration of the atoms. Now let's see the electronic configuration or electron arrangement. We know that at the center of every atom there is a nucleus. It contains proton and neutron, and around the nucleus there are circular paths, and in these circular paths the electrons are constantly circulating, remaining in these are called energy level as well, remaining in this energy level. So here we are showing the three energy levels of three shells, and in this shell we have already learned it in atomic chapter. That is not particularly the topic of this chapter. We know that two electrons are available in the first shell. Second shell is a bit larger, so it contains 8 electron, and third shell contain 8 electron as well. Up to hydrogen to calcium, this for first 20 elements, there are 8 electrons available in the third shell as well. So this is a kind of rule. The third shell will contain 2 electron, second shell will have 8 electron, and third shell will have 8 electron as well. Well, let me change the slide. This is a rule because whenever the electrons will carry this number of particular number of electron in different shells, in first shell, second shell, and third shells, then the atom will be stable with this number of electrons, and otherwise it will be unstable. Okay, let me change the slide now. We know that noble gases, that means group 8 elements, these are stable because they are completely filled, and that is why they are a bit unreactive type. So rest of the atoms will try to follow the noble gases because they are noble. Every element, every atoms try to be get the configuration like noble gases, okay, and try to be unreactive like them. You can just go through the elaborate explanation given here. Well, I hope you understood. And if you do not understand, you can read the same slide again and again, and you can also ask question to make it clear for you. Okay, let me change the slide now. Now, in this slide, we are going to see the type of bonding available we are going to learn in O-level syllabus. So there are three types of bonding: ionic bonding, covalent bonding, and metallic bonding. In ionic bonding occurs between metal and non-metal atom. For example, sodium chloride is an example. There are so many examples, but we have just mentioned one. And covalent bonding is a type of bonding which occurs between non-metal atoms. For example, iodine, methane, chlorine as well. And metallic bonding occurs between atoms in a metal atom, in a piece of metal. Well, so this we are going to learn these three different types of bonding in O-level syllabus. First, we have to learn in this ionic bonding in this video. I'm going to change the slide. Okay, before forming ionic bonding, first we need to understand how the ions are formed. After forming ions, they will go for forming ionic bonding. So let me explain it. Well, actually, the charged particles are called ions, right? Ions comes from the atom. Atom is a neutral particle, but whenever atoms will be converted into charge, when they will convert into charge, when they will gain or lose electron, then definitely they will convert into ions. So they will be converted into charged particle, and those charged particles are called ions. So ions are basically two types. These are positive ion and negative ions. Positive ions called cation and negative ions are called anion. So now the question is why electrons will be gained or electrons will be lost from an atom. Actually, they will gain or lose the electron to get the configuration of noble gas. And we know that noble gas contain 8 electron in the outermost shell. So that is why all the atoms have the tendency to gain 8 electron in their outermost shell so that they will gain the configuration of the noble gases. I hope you understood. I'm changing the slide now. Whenever in the normal state an atom is neutral, that means it has equal number of electron and equal number of proton. But whenever electron will be lost, then it will be converted into a positive ion. And from an atom, when the electrons will be gained, then it will be converted into a negative ion. To clarify it, we are going to give so many examples in the next slide. You can right now you can just go through the explanation given here. Well, I'm changing the slide now. Now, first we have to learn how the positive ions are formed. We know that metal atoms contain one, two, or three electrons in the outermost shell, like the elements of group 1, 2, and 3. They have the tendency of having one, two, or three electrons. So they are far away to have eight electrons. So it is very difficult for them to gain six, seven, or sorry, five, six, or seven electron to get the configuration of noble gas. Rather, they should have the tendency of losing that one, two, or three electron. It will be easier for them to lose the electrons. So you can understand that the metal atoms have the tendency of transforming themselves into a positive ion after losing one, two, or three electrons from their outermost shell. For example, group 1 elements have one electron. So it should have the tendency of losing that electron so that it will gain the configuration of nearest noble gas, that is helium. Only helium, among the noble gases, only helium have two electrons. So lithium should have the tendency of losing that one electron to get the configuration of helium, and by this way to be stable. Magnesium, its electronic configurations are shown here, and you can see as it has 12 electrons, so its electron distribution will be 2, 8, and 2. So to make itself noble or stable, it should have the tendency of losing that two electron and to get the configuration of neon. And like the similar way, aluminium should have the tendency of losing three electrons to get the configuration of neon again. So that means you can see that all the metal atoms have the similar tendency. They have the tendency of losing the electrons, and by this process, they have the tendency of converted itself into a positive ion. Now I'm gonna change the slide. For more for better understanding, we can show the number of electrons and the charges. It is the charge of an atom like sodium. In overall, the charge is zero, you can see, because that is as it contains equal number of proton and equal number of electron. But whenever it will to become unstable, it should have the tendency of losing the outermost shell electron. Only one electron, it should have the tendency of losing that electron, and by this process it will be transformed into a Na plus ion. Okay, so I'm showing here for all metal atoms the similar thing will happen. Now let me show you the next slide. For magnesium atom, you can see that it should have the tendency of losing two electrons and to become stable by this process. So it will be transformed into Mg2 plus as it group. So you can see that we can predict the charge by looking at by checking their periodic table, because in the periodic table magnesium is in group 2 elements. So all elements of group 2 should have the tendency of losing two electron, and by this process to become 2 plus ion. Okay, so from the periodic table we can predict the charges. I'm changing this slide now. Now, how the negative ions are formed. Negative ions are formed usually by the non-metal atom, because non-metal atoms contain usually 5, 6, and 7 electrons. So to get the configuration of noble gas, they should have the tendency of gaining electron, because it is easy for them to gain 1, 2, or 3 electron rather than losing 5, 6, or 7 electron. So after gaining electron, it will be transformed into a negative ion. Let me explain it. Look at the explanation here. Look at the examples. Chlorine has 17 electron in its shell. So its electronic configuration will be 287. So it should have the tendency of gain one more electron to get the configuration of argon. Similarly, oxygen have the tendency of gaining two electrons to get the configuration of neon. And nitrogen has the tendency to gain two more electrons to get the configuration of neon again. I hope you understood. So non-metal atoms have the tendency of gaining electron and to be a negative ion or anion. So for more clarification, look at the explanations. The fluorine will gain one electron to more to get the configuration of neon, And here we can see it, how the neon will be transformed into neon, fluorine will be transformed into F minus 1. This is fluorine. Not only fluorine, fluorine is in group 7 element. All elements of group 7 have the tendency of gaining one electron and to be transformed into minus 1 ion. Sulfur, number of electrons are 16. So its electronic configuration, you can see that it is 286. So it should have the tendency of gain two more electron, and by this process it will gain the configuration of argon. So its charge will be minus 2. Sulfur is an element of group 6. All the elements of group 6 have the same ion, that is 2 minus. Sulfur, oxygen, and all other elements of group 6. So you can get ideas of the electronic configuration on how the charges of the existing showing elements. These are like, first one is calcium, so it should have the charge of +2. Hydrogen will have only one electron, so its charge will be +1. Phosphorus, its charge will be -3. Fluorine -1, and beryllium, its charge will be +2. Okay. So I hope you understood, as we have already explained it in the previous slides. And if you do not understand, please let me know. And also you can check after the class, you can also check my videos again and again so that you will understand it. For ion, you can see the number of electrons will be either more or more than proton or less than proton. So the number of electron will be either same number of proton or less. If it is negative, then the number of electrons should be more than proton. That means oxygen is charge is -2. That means oxygen's protons number is 8. So its total number of electron will be 10. So its electronic configuration will be according to the number of electron. And fluorine as well, its actually proton number is 9. So here electron number will be 10 because its charge is -1, which needs to be added with the proton number. Because this number of electrons are more than the proton number. And atom is normally neutral. But whenever it is -2, that means here number of electrons are more than proton. I hope you understood. And if you do not understand, please let me know. You can just go through the page and let me know whether you have any problem or not. Let me change the slide now. What is a compound ion? Okay, so here we know that some in case of some atoms, they may sometimes they make a group of atoms, and whenever they participate in a chemical reaction, they work like an atom. That group of atoms make a group in such a way that in the chemical reaction, they works like just like an atom. A group, several atoms form a group, and that group just work like an atom. So the examples are here: hydroxide, sulfate, nitrate, carbonate, ammonium. In every case, they form a group. Like hydroxide, it form with one hydrogen atom and one oxygen atom, and OH, and its charge, it has also a charge which is -1, And it works like, as I have mentioned, it works like just like an atom. So here you have to remember the charges. Without remembering the charges, you cannot write their formula. Whenever they are available in a formula of a molecule, then you have to be able to know the charges to write down their formulas properly. So, students, I will suggest you please memorize the charge of this particular radicals. OH is called hydroxide, then sulfate is charged in -2, nitrate is charged in -1, carbonate -2, and NH4, that is ammonium ion, that is +1. These are called actually compound ion or compound radical. And whenever they will participate in any chemical reaction or they help to form a compound, they participate to form a compound. In that case, always they will remain together just like an atom. I will show their uses more in the later slides, don't worry. Well, now let me show you ionic bonding. When an ionic bond happens, we know that ionic bond like sodium chloride is formula is NaCl. That means here the ratio of sodium atom and chlorine atom is 1:1. Okay, so it is seen that each sodium atom is surrounded with six chlorine atom and each chlorine atom is surrounded with six sodium atom. That is based on their spaces around the radius. So by this way, the sodium innumerable number of sodium atom and chlorine atoms are held together very strongly to form a larger piece of ionic compound that is called actually lattice. And you know that this ionic bond is formed by the attraction between positive metal atom and negative non-metal atom. And this is their attraction force is maximum highest because you know that electrostatic attraction between two opposite ions are very high. So that is why they held together very closely with great melting and boiling point because their attraction force is so high that you cannot break them so easily. You have to apply very high temperature to break them. And they form this type of compound due to the idea of having a stable configuration by their atoms. Like sodium is losing one electron to form Na plus, and chlorine is gaining one electron to become Na minus, Cl minus. So by this way, sodium chloride bond is formed. Okay, I'm showing it better in the later slides. Look, it is sodium. It should have the tendency of losing one electron. By this way, it becomes Na plus. And chlorine have the tendency of gaining one electron more. It is group 7 element. And by this way, chlorine will be Cl minus. So whenever sodium and chlorine will get together, one will lose electron, another one will gain electron, and by this way, one will be transformed into positive ion, another one will be transformed into negative ion. So there will be huge attraction between sodium ion and negative ion, and by this process, sodium chloride ionic bond is formed. I hope you understood. And here, students, it is also called dot and cross diagram because one atom is used dot to show the electron and atom is used cross to show the uh, electrons. So dot and cross diagram will give you better explanation. Here you can see that chlorine has already 7 electron, but to become 8, it gains 1 electron from chlorine, and that electron is shown by giving a cross. So sodium chloride is formed. You can see sodium chloride. You can just go through it and let me know whether if you have any problems or not. Well, I'm gonna change the slide now. Look at the fill in the gaps. When atom loss or gain electron, they become what? They become positive ion, right? Atoms of metal. The fill in the gap here it will be. You have to take from here. Take words from here. Atoms of metals lose electron to empty their outer electron shell and positively become positive ion, right? Atoms of non-metals gain electron to fill their outer electron shell and become negative charge. That is not, that didn't come here. Okay, I'm changing the slide. I hope you understood how to do the fill in the gaps here. Now we have to learn the formula or how the formula of ionic bonds are written. It is very important. Without, you have to learn how to write the formula. If you do not know how to write down the formula of the ionic compound, then you cannot do well in the O-level exam. So let me explain it. Okay, here you can see that in the first example, one sodium is lost and that electron, one electron of sodium is lost and that electron is gained by chlorine. So NaCl is formed. So here the combining ratio is 1:1. But in the next example, also two magnesium electrons are lost because magnesium has two electrons in the outermost shell, and that two electrons will be gained by oxygen because oxygen has six electrons in the outermost shell. So it should have the tendency of gaining two electrons. So by this way, Mg2 plus and O2 minus is formed. So here the ratio is also 1:1. So you can see that the formula depends on the ratio of electrons gains and lost. In sodium chloride, the ratio is 1:1, so the formula should be NaCl, and magnesium oxide ratio is 1:1 as well, so it will be MgO. Let me change the slide. Here are more examples. You can see here a bit different types of formula. You can see whenever sodium is forming bond with oxygen, then sodium is group being an element of group 1. Sodium will lose one electron. Each sodium will lose one electron. But on the other hand, oxygen is a group 6 element. So it has two electron short. So it should have the tendency of gaining two electron. And that two electron should come from two sodium atom. So by this way, Na two sodium ion will form bond with one oxide ion. So here the ratio is 2:1, right? So the formula will be Na2O by this process. In another way to understanding it better is sodium is group 1 element. On the other hand, oxygen is group 6 element. So whenever anything is group 6 element, its valency should be 2 because 6 will be subtracted from 8. 8 then it will be 2. And sodium is being an element of group 1, its valency is 1. So whenever you will exchange the valency, it will be Na2O. So once you exchange the valencies of charge or the charge number, then you will get the correct formula. Sodium's charge is +1, oxygen's charge is -2. So whenever you will exchange it, it will be Na2O. So that is another understanding of how to write the formula. I hope you understood of writing formula. If you have any confusion, please let me know. Being an element of group 2, oxygen's valency is +2. And being an element of group 7, chlorine's oxidation is valence is 1 because it has the tendency of gaining one electron more. So if you exchange it, it will be, if you exchange the valence, it will be MgCl2. So by this process, you can write down the formula. Well, students, let me change the slide now. Actually, writing formula depends on all these 4 points. First, you have to write down the symbols, constituent symbols. Constituent means the element which are available in a formula. So, for example, water, if you go for writing the formula of water, water contains two constituent, hydrogen and oxygen. So, you have to write down the symbols of the formula side by side. Here, you have to write the positive one first, then negative one. Then second one is calculate the charge for each type of atom. Yes, to make sure you know the valencies, and the valency comes from the charges, as I have explained. And then whenever you will exchange them, then it will be properly balanced. That means number of electrons should be equal to the number of proton, because a formula or a molecule itself is a neutral particle. So number of positive ion and number of negative ion should be equal, so that they can cancel each other. And when they will equal, when you will exchange the charges properly, then you will get the neutral particle of a molecule. I hope you understood. Look at more elaboration what I have explained. Aluminium being an element of group 3, its charge will be +3, and being an element of group 7, bromine's charge is -1. So you have to exchange the charge number. It will be 3, 1:3. That means one aluminium should combine with 3 bromide ion, because of the valency or combining capacity. So whenever you will write the formula, it will be AlBr3. Okay, just AlBr3 we need to write because of the charges, number of the charges. Okay. Whenever you will exchange the positive charge and negative charge, it is 1:3, and by this process, the formula will be AlBr3. Every time whenever write the formula of anything, you have to follow this format. Whenever you will write aluminum oxide, you see that aluminum is a group 3 element and its charge is +3. And if you check the periodic table, oxygen is group 6 element, so its charge is -2. So if you exchange it, then it will be 2:3, and the formula should be Al2O3. I hope you understood. All the formulas are formed by the steps which I have explained before. You have to write down the constituent symbol of the constituent element side by side. For example, whenever you go for writing calcium fluoride, then calcium its symbol is Sc, and fluorine its symbol is F. So you are going to write the symbol side by side, CF2. Then you have to exchange the valences. Calcium's valency is 2 and fluorine's valency is 1. So whenever you exchange the valency, it will be CaF2. The valency is directly related with the charge. Okay. So all the formulas have been calculated by this procedure. Now you can practice writing formula of any compound. In case of compounds which contain radicals, you have to remember the charges, because the charge will work like a valency. Suppose CO3 has two charges -2, that means its valency is 2. So if you go for writing calcium carbonate, and if you exchange the charges, it will be CaCO3. But if you go for writing sodium carbonate, it will be Na2CO3, because sodium's charge is +1 and carbonate's charge is -2. So if you exchange it, then it will be Na2CO3. I hope you understood. So you know the correct formula is LiNO3, right? As the ratio is 1:1. Here we have used a compound radical like NO3. Its charge is -1. So its valency we can consider as 1. So lithium is group 1, so it is 1, and nitrate is also 1. So if you exchange it, it will be LiNO3, 1:1 ratio. I hope you understood. I'm changing this slide now. Well, this is almost the last topic of this chapter, some properties of ionic compounds. As I have already mentioned, ionic compounds are very strong as here the attraction works between two oppositely charged ions. Electrostatic attraction force between positive and negative ion is very strong. That is why its charge is very strong and its melting point, boiling point is very high. So our first property must be the ionic compounds is very strong and it has high melting and boiling points, and it needs very high temperature to break it because of that high attraction. Whenever innumerable number of sodium and innumerable number of chloride ion available in a piece of ionic compound, it forms a lattice structure like this. You can see here the cubic structure of sodium chloride. And you can see the melting point of sodium chloride is very high, 801. But melting point of other compounds which have more charges, they should have more attraction between opposite ions. And there, in that case, the melting point, boiling point will be higher than even this one. Look at the example. Magnesium oxide contains +2 and -2 charges. So here electrostatic attraction force is even much higher than sodium chloride. And that is why it is more than double on the melting point of magnesium oxide than sodium chloride. So more charges, stronger electrostatic attraction force. Which substance will conduct electricity? Actually, we know that metals conduct electricity, and if we try to know what is the reason is metals contain delocalized free electrons. Those free electrons are basically responsible for to conduct electricity by the metals. But another type of substance like ionic compounds, they can also conduct electricity by the opposite ions. For example, sodium chloride, but sodium chloride cannot conduct electricity in all forms. Whenever sodium chloride is in solid form, then they are held together by very strong attraction force. The ions cannot move from their position. They can just vibrate. That is why solid sodium chloride cannot conduct electricity. But sodium chloride in the solution state, the ions are free, and in that state it can conduct electricity. Again, in the liquid state of sodium chloride, also the ions are free and it can conduct electricity. Diamond cannot conduct electricity because that is, first of all, it is a non-metal, and usually non-metals are unable to conduct electricity. But graphite is an exception in the non-metals, as graphite, although graphite is a form of carbon which is a non-metal, it should not supposed to conduct electricity. But graphite, in its structure, it is seen that one electron of graphite is delocalized, and due to the presence of the free electrons of that one electron, graphite can also conduct electricity a bit. I'm changing the slide now. You can understand why the molten state of sodium chloride is capable to conduct electricity and why the solid state cannot conduct. From this explanation, I hope you will understand it better. And still, if you have any confusion, please let me know. Just go through this slide. I'm changing this slide now. Well, so we have finished the chapter topics. there are some topics which will be very important for you. You can take a note of these topics like what is bond, what is compound ion, ionic bond, ionic compound, ionic lattice, negative ion, noble gas, positive ions, and all. And that's all of ionic bonding. I hope students you have understood it and you will go through the points and explanations given in this video. And if you have any problem, please let me know. Thank you very much.